Let's look at box 2 in chapter 8 of your Ruddiman text to discuss sine waves. Now, sine waves are used for modeling cycles. And Earth's and the orbital controls on insolation that we're going to be going through this week are cyclical. So it's really important to be able to grasp what these different graphs in the book are telling you and showing you. So let's begin by looking at this circle up in the top right here. And let's start by pretending the circle represents Earth's orbit about the sun. So this red circle I just drew, this smaller circle, let's pretend that's Earth. And it's orbiting around the sun, and we all know that it takes 365 days for Earth to orbit around the sun. Now, direct your attention to this plot on the bottom of the screen here. This is showing a sine wave, all right? This wavy curve. And in this particular instance, we're seeing one wavelength. And so you'll notice that this curve starts and ends at 0. Now, on the x-axis here, we're looking at angular velocity, which is represented by omega. That W-looking thing is the Greek letter for omega. And you also see that the axis goes from 0 to 360 degrees. Now, looking at a circle, if you can remember from geometry, there's 360 degrees in a circle. Now, let's pretend that this red Earth circle up at the top here is our baseline. So that is 0 degrees. So that is going to be over here on our axis. And what we're doing is we're drawing a circle over time. And actually, it might be a little easier if you think about, let's make this our starting point. I think it'll be a little easier to visualize if we actually start there. And you can also think of the sine wave as being a time series. So if we know that it takes 1 year, or 365 days, for Earth to complete one full orbit about the sun. So starting at this x down here and this x up here and moving in this direction, what we're essentially doing is drawing a circle over time. So as we move along the sine curve, it's the same as our motion about the circle. And so then as we come back around, so we're going and drawing our circle over time. So this would be the lower part of the circle down here. And then we're going to finish where we started at the x. And that's all the sine wave is showing. It's showing a cycle. How long it takes, one wavelength represents a circular cycle. And so wavelength is going to be shorter, more squishy when you have quicker cycling. And quicker cycling would be higher frequency. So frequency is 1 over the period. And the period is the length of time it takes to complete a cycle, right? So a wavelength. Now, just think about that a little more when you're going through this, and hopefully this will help you visualize some of the graphs and try to go through and interpret these different plots on your own. So think about the wavelength and the frequency and what it actually means to complete a cycle.